Hi there, I'm Brian, and in this video, we're going to be going over how I trained in RNN to generate Lofi Hip Hop. So to start things off, I kind of just wanted to talk about what Lofi Hip Hop is and kind of what it means to me. I think it was my second year of college when I discovered the music. There was this YouTube channel called Chilled Cow, and even though it's famous now, back then it was little more than a curiosity on my front page. But as soon as I tuned in, I couldn't stop listening. It became the go-to study music for my college years. Now, for those who don't know, if I could describe lo-fi hip-hop, it's kind of like a repetitive, ambient kind of music, but it really helps me focus. And there are a few people who don't like lo-fi hip-hop, and that's perfectly fine. But one of the common criticisms that I hear is that it's very simple or too easy to make. And that just begs the question, if it's so easy to make, can we train a computer program to actually make it? Well, let's find out. So first we need some data. And luckily, there are some people who have already generated music using neural networks, and we're kind of going to be piggybacking off of their data. Specifically, we're going to be using the pretty large compilation of lo-fi samples from Nina Tremblay. In this dataset, we have a bunch of MIDI files, which tend to be a little bit easier to work with programmatically using Python. With the data in tow, we can talk about our model. For this project, we're going to be using an RNN, a recurrent neural network, which works really well with sequential data. And since music can be thought of as a sequence of notes, I thought it was a good fit. Specifically, we're going to be using the long short-term memory architecture. We're doing this because we want to keep track of things that have happened in the past. So what exactly are we trying to predict? Well, the way we're going to think about things is that we're going to take a sequence of notes, chords, or rests, and based on that sequence, we're going to predict what note or chord comes after. After training such a model, it will be possible to generate music. So the way we're going to use this model to generate music is we're going to take a note, let's say C, and predict what note will come after. And let's say the output is E. After this prediction, we're going to put E back into our input, and with that input, we're going to predict the next note that comes after. Let's pretend it's G. We put that back into the input, and this process repeats all the way until we're satisfied with the length of our song. Once we have all of the notes, then we can use Python to take that sequence of notes and then actually turn it into music. With all of that said, let's take a look at some of the code. So here we have the notebook, and let's just walk through some of the code. So no surprise here, we're going to start with a bunch of imports. Specifically, we're going to be using glob to help with directory browsing, numpy for data manipulation, TensorFlow for the actual neural networks, and Music21 for handling our music processing. Now we can move on to the data processing. First, we take all of the files inside of our dataset, we parse them, then we take the primary instrument of all of the files. In this case, it's usually the piano. And we take that instrument and get a list of notes, chords, and rests. With that list of notes, chords, and rests, we put them into our dataset. Now that we have a sequence of all of the notes inside of our dataset, we create a dictionary for all of the unique notes and chords we find inside of our data. Next, we create our training set by creating sequences of 15 notes, and for our expected output, we take the note that comes after those sequences. Lastly, we do a little bit of tidying to our data to make it play a little bit better with TensorFlow. This includes things like reshaping the data so that it has an extra dimension, or dividing it and normalizing the data so that it's on a scale from 0 to 1. For our model, we're using 3 hidden layers with 256 parameters, 512 parameters, and 256 parameters. In between each of these layers, we have dropout layers, which we included to make sure that our model doesn't overfit to the data. We set up a callback so that we can save the best performing weights during training. And finally, we fit our model. With our model trained, we're ready to generate some music. We start with a loop that allows us to create 5 songs. For each song, we choose a random starting point from our input dataset. And with that starting point, we begin that process of predicting the next note, putting it back into the input, predicting the next note after that, and continuing that 500 times, giving us a song of 500 total notes. Once we have that sequence of 500 notes, we begin to create the MIDI file that we can actually listen to. So, for every element in the sequence of our song, we create a chord if it's a chord, a rest if it's a rest, and a note if it's a note. After that, we add it to the song based on the time offset that we're currently at. Once that's done, then we increase the offset so that the song can continue. And lastly, we save the MIDI file. With the code out of the way, let's listen to some of the results. Here is the first song that I was able to generate. How did this happen? Who was responsible? I tried to figure out what could have possibly gone wrong. One thing I tested was maybe I didn't train the model long enough, so I increased the epochs and same result. Another possibility I thought of was maybe the sequence length was wrong, so I ran an experiment and used various sequence lengths, and even though I was able to find a more optimal sequence length, same result. So there has to be something else, something I can do to make this model better. And the answer is Final Fantasy. You see, you might have noticed this inside of our dataset, but all of the clips are relatively short, unstructured clips of Lofi Hip Hop samples. And once we combine all of these clips into our dataset, it's just absolute chaos. And the model ends up learning that. So I figured what I needed to do was to find a new dataset filled with long-form, structured songs that all have a consistent mood. On top of the restriction that with the way my code works, I could only work with MIDI files. Could such a magical dataset exist? Well, yeah. Final Fantasy. As a longtime fan of the video game series, I knew that the title screen always had a consistent "Adventure Awaits" kind of song, and all of them shared a similar musical feel. Not to mention, the MIDIs for these songs were online. So, I downloaded all of these MIDIs and created my new dataset. Here is what a model trained on that dataset sounds like. Now it's time for some final thoughts. Nothing is perfect, and this project certainly wasn't perfect. But even though I wasn't able to make lo-fi hip-hop in the end, or even hip-hop in the end, I'm still happy and proud of the song that this program was able to create. I mean, some of the notes in the beginning actually evoke a little bit of emotion out of me. And I might just be biased as the creator of this program, but I genuinely think it's amazing that this computer program was able to create music that evoked an emotion. To me, that in and of itself is amazing. But in terms of improvements, I think that there are many ways you could go. Some of the things that come to mind are getting more songs, maybe getting longer songs with more structure in them. I also thought about maybe taking a page from NLP models and creating something similar to word embeddings where we create note embeddings. I think it'd also be effective to include some of the order in notes, because notes do follow an inherent order. Either way, there are many ways you can improve upon this work, but I'm still happy with the results I was able to create. But I'll probably still be listening to Chilled Cow instead.